The switch statement comes into Java when I have essentially the alternative of creating a whole bunch of else if statements. We saw, you can say if Monday, else if Tuesday, else if Wednesday, else if Thursday, else if Friday. That's the example we finished with at the end of the if statement. Whether you watched that 2 minutes ago or whether you watched that a while ago, that's what we talked about. So the switch statement comes in when I have data like that. It's discrete, meaning there's individual choices to make, not continuous basically is saying 1.3, 1.3.1, 1.32, 1.33, 1.331, the real numbers right there. When we say discrete, we have very clear choices, integers, 1, 2, 3, 4, 5, or text, specific things. So let's look at this example here where like the year of the zodiac in the Chinese calendar. So if you're born in 1974, you're a tiger. If you were 72 or 76, you're a rat. So there's a cycle to it. By the way, there's a bunch of ways we could solve this problem, but we're using if then else statements for this. And that's true of a lot of code, by the way. Not everything has to be solved in the same way. There's often many solutions, and some might be more elegant than others, but that's about really getting to answers, not necessarily which code you use in some cases. But for now, we're talking switch statements. So I could do an if then else switch statement. If it's 1974, then it's tiger. Else if it's 72, it's a rat. Else if it's 96, it's a rat. I could do some structure like that, but the switch statement gives us a simplified way of cleaning up that code and making it a little bit more readable. So the basic switch statement goes to a single variable instead of a single Boolean, a single variable. So for instance, birth year. And then that switch statement right here, you can see, takes that birth year inside a parentheses, switch on the birth year, and then has the curly brackets again. Curly brackets are really important in these logical structures. And inside of there, there's a bunch of places I can jump to as signified by the case statement. When I see the word case, right after that comes a clearly defined constant value. It could be a literal, in this case, 1974. It could also be a constant, a final variable that's declared out there. So when I see the case, if the value is 1974, I jump to that point in the code and I execute down from there. So the answer is tiger. And then you see the word break inside of there. Break is a reserved word in Java that says, okay, stop what you're doing and jump to the next end curly bracket. All right. So when I see that break, I leave that code, jump down to the final curly bracket, I skip the rest of the code. Now, in some languages, the switch statement, when I hit the next case statement, automatically breaks. That's not true of Java. So in Java, you can see whether it's 1972 or 1996, both those cases are right next to each other. And so at this point, when I hit either one of them, the assignment would be rat. You would say you are, in this case, a rat. Now, and then you hit the break after that. And you can have any number of these inside of here. But that's the foundation of the switch statement. The switch statement then gives you these options of jumping around in your code based off of a single value, in this case, the year. The cases, as I said, must be a literal or a constant. I can't have a variable inside of there. I can't say, sometimes it's this, sometimes it's else. It has to be something that can figure out at compile time where it's jumping around to. Now, that automatic drop through can be something that's very intentionally designed. It does not break unless you tell it to. So in this next example, which is syntactically, just a case statement, there's nothing special about this syntactically, but logically speaking, the problem we're trying to solve is installing some software. And so I asked the user, do you want a full installation? Do you want a standard installation? Do you want a minimal installation? And so this is actually kind of a little bit backwards. So if you want the minimal installation, you're only loading the executable. So I have this installer method I'm calling load executable. So I have an object called installer, and on that object I have .load executable. Now, if I want the standard installation, I want to load the sound files and the executable. Now, assuming I can load the sound files before I load the executable, I mean, I can't violate all the rules of my logic and needs. But I can, at this point, when I get the value of standard coming in here, installation level is equal to standard, it jumps down to standard installation, it then loads all the sound files, and then it comes back and loads the executables. So if I can do them backwards, then I can do that just fine. When I get to full, it starts off here, it loads all the videos, and then it loads all the sound files, then it loads all the executables. And so it passes through. It jumps to that point and keeps executing on down. It doesn't execute backwards all of a sudden. We're not changing the rules of code. We're not, we read top to bottom on the page all of a sudden, but it will let you pass through, assuming that the logic fits, assuming that the logic works. So this allows me to a lot of flexibility in how I can structure my data and be able to use this structure. The switch statement, though, can be tricky in that if I do something like an integer, we saw before, what if I put in the year 2574? That's a long way from now. Do I have to code all those values? Or in this case, I have a number guessed in the game. I have an integer. Well, an integer has 4.2 million possible values that you can represent in Java. They're all discrete values. They're very clearly discrete values that you can represent, but they are limited. But they are really, really big. It'd be a lot of coding to do. So what Java gives you in the switch statement is this term default. And so in the term default, it's saying if none of the other cases apply, go to the default case. So I have a number guessing game where the answer is always 67. Again, it has to be a constant. I can't have a variable inside of it. This logical structure wouldn't work for something that's not a constant. Now, mind you, there's ways of tricking that. I can have a constant just for that run of the code. I can go run it again with a different constant, but I couldn't do it for, it depends on the context. You have to be, it has to be careful inside of that. But here, so we have the number 67. So the answer here is when does 67 you win? Any other time it says try again. So you have the player guess that comes in, as long as they haven't picked the number, they have to try again. So whether they pick negative 50 or positive a million or negative 2 million, the answer is going to be try again unless they pick the right number, 67. The default does not have to come last here. There's no rule that says the default has to be at the end. Some languages have silly rule like that. I can put the default anywhere inside of here. It can be in the middle because remember, it jumps to wherever you want it to. The default behavior could be doing everything. And so you want to have the default be the first thing instead of the last thing or somewhere in the middle. So that's the way the default works inside of the switch statement, is allow you to make that jump. That whenever no other case matches, then the default gets executed. I already said that. And again, the default doesn't automatically break. You have to tell it when you want to break or if you want it to break out of that default. So the syntax of the switch, just to kind of shore this up a little bit, make sure we have it very clearly. It has a variable inside of there. That variable has to be a character, byte, short, or integer for the original versions of Java. For the most recent versions of Java, it adds in enumerations and strings. Originally, Java did not allow strings. Now Java does allow strings because strings are discrete. There's very exact values of them. I can have one or many case statements inside of there that is identified by a literal or constant value. A literal being a number or string or otherwise some discrete value typed into code, and enumeration is the other one there. Or I said instead of constant, you're allowed to have a default inside of there for the default case, and then the break jumps out of the switch statement by going to the last curly bracket at that point and executing the code from there. It doesn't just jump out of the current case, it jumps all the way out of the whole switch statement at that point. All right, so the question here is, when do I use an if-then-else statement? When do I use a switch? Well, the switch is the best one if you can get it there. But it's very rare that I have data set up where I'm going to jump to one of several places on that variable. Normally, I have to validate that value ahead of time. Normally, there's only one or two things I'm going to do. So this sort of control structure can be useful for, like, say, a command line GUI sort of operation. But when I get into command line operation, the text operation. When I get into GUIs, it's not as useful anymore. Normally the person will hit this button or that button or something like that. So I'll be honest, I don't think I've probably coded 10 times in production code an actual switch statement. Most of the switch statements I do are for teaching or learning purposes. They do come up occasionally. You can occasionally arrange your code, and they're really useful when they do come up. So the if statement is better or absolutely essential when I have a range of values. So if I want to say if the temperature is greater than 50 degrees but less than 80 degrees, that's much better, because not only can I deal with real numbers, because the temperature could be 50.2 degrees, but also I don't have to put in a whole bunch of different cases. I can just say those equal, then, greater than, less than. Or if the data I'm working with is not one of the base types that we talked about in string. Again, even strings can be tough, because in a switch statement, I have to type exactly that string. I can't use capital letters differently. I can't spell it differently. At least as far as an if then else, I can use the equal ignore case method and be able to get a little bit easier there. So that's the switch statement. It is really cool. It is really helpful when you can use it. So definitely play with it. Just don't force it into the situation. If you can't easily use the switch statement, you probably should be using an if then else statement.